Everybody, welcome to the last lecture in web engineering this semester. Thank you all for coming, even though this is not relevant for the exam, so I'm happy to see a few faces here and a few online, obviously. Today we're going to start off with a guest lecture from Christian Cito. The last name is not a coincidence, he is my brother, who happens to be also a very talented web engineer. So I asked him to come here and talk a little bit about the projects he has done in the past, specifically the aspects we haven't quite gotten into as part of web engineering. Things like, how do you scale an application? How do you deal with databases? Like the stuff that we couldn't do because we are constrained in the credits that we have. After Christian's talk, what I want to do is sort of an ask us anything session that can be 2 minutes, that can be 20 minutes, whatever you prefer, right? Like depends on you, whatever questions you have. The only program point I have is I want to ask your feedback on this year's edition of web engineering, specifically with an outlook to next year, where we're going to shift from 3 credits to 6 credits. So we're going to be able to go into a bit more depth, cover some more topics. We have some ideas there. We want to share them with you and just get your opinion as to what you like this semester, what we should keep, and what you would have liked to see, right, for people next year. So yeah, let's start off with the first point. Christian has been a developer for 11 years now?
Around 11 years, yeah.
11 years. Specifically in the web field. I think you started in the web field. You sort of stayed true to those colors. You're going to talk a bit more about your background also, so I'm going to leave it at that. Thank you, Christian, for being here, and take it away.
Thank you, Jürgen. Can everybody hear me good? Nice. Cool. So I'm Christian, and I'm going to talk about the anatomy of a modern web application. So first off, a little bit about myself. I've been doing web development since 2011, around that age. And I actually was Jürgen's first student, because he taught me the basics. I went to the same HCL as Jürgen, where I learned like the basics of computer science. And I started freelancing while I was in school. So at around 15, I had my first commercial project, which was like a blog for some musicians. And after school, I worked for Xing for a few years. And if you don't know Xing, which is probably something you don't know, is like the German LinkedIn, just a bit worse. And one thing about me is I love doing side projects. So I'm going to walk you through a few projects I did in the last couple of years. And I'm going to start off with a short film festival. I got approached by the mother of a friend of mine during COVID, because their festival she was hosting every year was not possible to host in the cinemas due to COVID. And she asked me to make a web application of this festival where people can log in, vote on the films, and of course watch them as well. The next project is like a bit of a passion project of mine. I really love this one streamer called Hassan Abi. He does like political content. And I made an app for his fans, which aggregates all the YouTube channels about him, around 50 to 60, into one web app. And I automatically get filters and tags out of the titles of the YouTube videos. The next app I made around 2 months ago is for the techno collective Hausgemacht, which I'm a member of. It's a check-in app which connects to a passport scanner, which allows you to check in your visitors to the party without actually need to know the name, because you just get the data of the passport and then you show it in this tablet UI. And most recently, I launched a web project with a friend of mine which tracks grocery prices in Austria, especially for Spar, Hofer, and Billa. You might know there's like a bit of a controversy about that in Austria right now for the Regierung. And lastly, what I'm going to talk to you about today is a web project I launched around 2 months ago called mitentscheiden.at. Here I got approached by some friends of mine in the Junge SPÖ, who, as you might know, there was an election internally in the SPÖ for the leadership of the party, and there were 3 candidates. And the youth wing of the SPÖ wanted to create an application which allows people to find out which candidate actually is the best for them. So this was an initiative by the youth wing. To make this possible, we had 41 questions which we compiled, which we had all the candidates answer. And then we created the app, which allows you as a voter to go through the whole questionnaire, just like the candidates, and give your own political opinion. And at the end, you get like a matching result with each candidate and like a ranking which one is the best for you. This, of course, is modeled after mitentscheiden.at, which, if you don't know, is a project which was co-created by Peter Pogerthofer. You might know him from Denkweisen der Informatik. And the whole thing took about 3 weeks from idea to launch. So, how does it look like? Well, the core part of the experience is a questionnaire where you can answer the following questions between if you like agree with the statement or not agree with the statement, or how much you agree with it, and how important the topic is to you. In the end, you get a result page with the 3 candidates and the matching score. I think this is even my matching score, but Andreas Babler was the first, obviously. And you also have multiple comparison pages where you compare the answers of the candidates between you and also between the candidates one by one. We also have multiple ways of adding a sharing story to this. The first was a shareable graphic, which I generated for every result page on demand, which allows you to share this result of yours on Instagram as a story or as a post or on Twitter. And I added dynamic open graph images so that when you share a link to Discord or WhatsApp or Twitter, it shows you like a nice graphic with your result. So, what were the results? Well, 27,500 people, around that, filled out the whole questionnaire. That resulted in about 3,000 hours of usage actually in the app. We had 550 peak concurrent visitors when we got featured in the T-Binds for, I think, 5 seconds. And overall, we generated about 400,000 Twitter impressions. And we got a few national newspapers to cover the project. So, how did I build this? Well, I used TypeScript as a full-stack language. I used React for the front end, Next.js for the front end and back end. MySQL as a data store, Prisma for interacting with the database, Tailwind CSS for styling, Vercel for hosting, and Planetscale for hosting the database. Now to the core part, the anatomy of a modern web application. This is, of course, a very simplified version of a web application, and there's going to be many different ways to architect this. But in the core part, you have data, you have some sort of server, and you have the browser where the user actually requests the page and interacts with it. And for your consideration, what you as a developer are thinking about, it is data, the routing, and the rendering of the page. And we're going to quickly start off with the data. This is the whole data model of the application. You can see it's very simple. You can probably figure it out in 3 minutes how the whole application works. And just as a quick 101 on databases and MySQL, this is how you query data from MySQL. You use SQL with the programming language, and you basically just define what you want. So in this case, we're defining I want the name, I want the title, I want the option, and just get me the data from these tables. And I want to filter it by Andreas Babler to get his answers to the questions. And this is what the data returned looks like. It's like an Excel table, basically. So what is Prisma, and why did I use Prisma for this? Well, Prisma is a library for interacting with databases in JavaScript or TypeScript. And it can define your database schema, handle database migrations, and most importantly, query, update, and insert the database while maintaining complete type safety. So what does it mean? Well, it's very simple. In your database, you define what kind of data is stored there. So every column has a data type, like string or integer or date, for example. And if you try to use an invalid data type, like here, it will just show you a TypeScript error. This is very simple, but very powerful because it will catch, let's say, 25 to 30% of the bugs you're going to have. So how do you query data with Prisma? Well, again, it's quite easy and quite readable. You just say, Prisma, get me the candidate table, and find the unique candidate for me. You filter by the slug, and then you just include the answers, and for every answer, you're going to include the question to the answer. And in the background, Prisma will compile the statement down to SQL. As you can see, it's a bit different than the SQL I showed before. That's because Prisma does some internal optimization to actually make the experience faster for the database. And this is how the data return will look like. So instead of having the duplicate data, like Andreas Barber the name like 5 or 6 times, you get just one instance of it. And you can just use this result immediately in your application without having to transform it beforehand. Now to the next part, and probably the core part of the experience, rendering and routing. So what is routing? What is rendering? A route, very simply, is a URL, which is the core of the web application. And a URL defines at what point what data needs to get fetched and what view code should render the data. And rendering just means executing the view code with the data together to create the user interface, which in our case means HTML in the end, because the browser can just understand HTML. And an important distinction is that routing and rendering can both happen on the client and or the server, depending on the paradigm you use. So, what paradigms are out there? I'm going to give you a quick history on the history of web rendering. And in the beginning, there were static files. The web was very simple, very in its early days. And you were requesting the HTML files in your browser just like you would request a file on your Google Drive or on your Dropbox or just on a remote computer. So the web was very simple, just static data and nothing else. And in the next iterations, we had dynamic servers. Now you can run backend code like C# or PHP or Ruby or Java to dynamically generate this HTML based on the routes. And you can access databases or other data sources to actually create an app-like experience or just something more than static files. Now to the next iteration, client-side rendering. So client-side rendering was basically a response of the web to what was happening to native mobile apps. Because users were getting spoiled by the experience of iOS and Android because it was so much faster, so much better, because all UI rendering was happening on the client. Back then, in the dynamic server era, every UI change happened on the server. We were requesting different data, different routes, and then you have to first go to the server has to execute its code, and then it has to send back the new UI code. And just the latency of that will be alone like 300 milliseconds, which is too slow. And client-side rendering just switches the paradigm, and instead of having the server do all the work, you move all this rendering logic to the client. So the server will just respond with an empty HTML and a big JavaScript bundle. And this bundle can go into the 5, 6, 7, 10 megabyte size. Then the client will execute this bundle. And after this point, the JavaScript in the browser will take over all actions for the rendering, like routing, like fetching data, and of course rendering the result to HTML. Now we come to the next iteration, which started around 2018, and this is server-side rendering. Here the server actually renders the page first on the server in a complete form with all the data, sends that HTML down to the user together with all the code he used to render the HTML page. Then the client can immediately show the rendered HTML, so the end user will get a nice first experience and it will show the full page of data. And the client will re-execute the JavaScript bundle to, yeah?
Yeah, can we ask questions in between?
Sure.
Yeah, so please feel free to interrupt him and ask questions. So I feel like you said server-side rendering in the last slide too, though.
Did I?
Right?
Oh, yeah. I did.
So you said dynamic servers. So can you explain the difference between dynamic servers and server-side rendering?
Yes, of course. So dynamic servers are just rendering on the server. It's a bit of a confusing naming, of course, but so if your PHP server, for example, gets a request and renders the HTML, it cannot send the same code it used to render to the browser because the browser doesn't understand PHP. The browser just can understand JavaScript, HTML, and CSS. So this is the reason why this paradigm is different than before, because server-side rendering is mostly something you do in full-stack JavaScript frameworks, which can handle both server and client, so the browser. And the important thing here is it's the same code. So the same code gets run on the server and on the client.
So my understanding was that in server-side rendering, you write Vue or React components,
Yeah.
and you sort of choose where do I want to render it. Is that?
That's wrong, actually, no?
Is it? Okay.
So this is kind of what the next bullet point, but in server-side rendering, you have minimal code which will run just on the server, where you can do database calls, but most of the view code will also just come to the client.
Okay, thanks.
Of course. So yeah, the client shows the full rendered HTML. It will then re-download and re-execute the same JavaScript code as before, and hopefully show the same results, because this code should be the same. And this JavaScript code will then take over the HTML page, and every interaction on that HTML page will then be handled by this front-end code. So if you click a button, yeah?
I don't fully understand the difference then. So why would you give the user the HTML plus the JS bundle if it's already been rendered? Would you just give them the result?
Yeah, because
Continue calculating it, isn't it just client-side rendering, but the first initial render is not client-side?
that's exactly what server-side rendering is.
Okay, fair enough.
Because if you think about it, you want to solve the...
Can you repeat the question, because usually the microphone doesn't capture?
Yeah, sure. So the question was, why do this? Because after rendering the HTML for the first time, it's just going to be client-side rendering again. And that's 100% correct. So the page will just bootstrap the first initial view, so the user gets a fast experience. And after that point, client-side rendering takes over, and all the routing will also happen on the client. So the front-end framework will then fetch the next page in the background and show it asynchronously. So it will not do a full page reload. Now, a good connecting point is the next and last iteration, which just kind of started happening in the last year, actually, which is server-side rendering with partial hydration. So what does that mean? Well, in most cases, you're kind of right. Why do you render on the server and then just do it again on the client? Many things just need to render once. For example, navigation or a logo or a footer. All this stuff, it just has no interaction and is just static. But in server-side rendering, it will still download the same JavaScript to re-render it, even though it will never re-render. Well, the solution to this is that the server will again server-side render and render all the HTML, send it to the browser, but will only send down to the browser certain components which you seem to need interaction with. So what that means is you have some kind of configuration which should tell the framework, okay, this component I want on the client, all the other ones just leave in the server. And this will result in a smaller JavaScript bundle, but also a smaller runtime, because the browser just needs to know certain parts. I'm going to go a bit more in depth into client-side rendering. As you can see, you have the server and the browser again. And with client-side rendering, one of the big pros of it is that you don't really need a server for rendering, of course. The server mostly was just some lightweight file CDN, which costs you basically nothing. This lightweight CDN, yeah?
What is a CDN?
Good question. A CDN is short for Content Delivery Network. It's basically, you can think about it as, let's say, 200 file servers all over the world, which is just responsible for hosting files and serving them very quickly. So there's no compute logic, it's just serving files. And so this CDN will probably be in Germany, in Vienna, in Budapest and stuff, because it's so lightweight. It can be all over the world, and it will respond very quickly to your requests. So the browser requests the index page, for example, and the server will just return HTML, CSS, and JavaScript. Then the browser does all the work and all the logic for rendering. So it downloads this empty HTML. It will show an empty page. It might show a spinner if you add it. And then, in this case, for example, React takes over. React will match the route you're at, then fetch the data inside of the front end, and then will render to HTML, which a browser can show. So why did we switch to this from dynamic servers? Well, the first, it's very cool actually to offload all rendering to the browser. It's something you don't own. It's something you don't have to pay for. It's something every end user has. So it becomes very cheap actually to render in this way. Then the other advantage is it's a very simple mental model. Everything happens in one context, and the context is the browser. So everything the browser can do, everything you can do in the browser can be in your code. Well, what are the cons of this? Well, one of the cons is you cannot access private data directly, because if you access a database, you need the database username and your database password, and you don't really want to give that to the end user. And everything which is in the browser, the end user can access. It's the same with private APIs, with API keys. You don't really want to leak that. And then the other thing is that the data fetching will only happen after all the JavaScript has been downloaded, parsed, and executed. So it can take around 500 milliseconds, 1 second, maybe 4 seconds until any data fetching even starts to happen. And this results into a very slow first page load. Many times it can take very long, especially with applications which are not architected well. And this also is not very much optimized for search engines, because Google expects a valid HTML with all the data in it in the first 2 seconds. And if it doesn't get it, it will just say, oh, it's an empty page, no content. I will not index this. Now to server-side rendering. Well, server-side rendering splits up the responsibility between browser and server. And so the browser, again, requests a certain page. For example, the candidate slug in the Wahlkabine. Then the server will match this route if it's internal code. It will fetch the data immediately on the server. Then it uses React to, for example, render this data to HTML and send that to the client. The client downloads this, shows the first UI with all the valid data in it, and then it executes the JavaScript to take this HTML over again, and every click which happens then afterwards, the React bundle handles again. So if you have a button which has a click handler on the page, if it's hydrated, which means if the JavaScript has taken over the page again, React will react to it. So what are the pros of this? Well, first, there's a fast initial response with actual data. So why is it fast? Well, one thing which the browser isn't is a controlled environment. A browser could be in a very bad network connection, maybe in the Deutsche Bahn or something. A browser can be low powered, like an old Android device or old iPhone. And on the other hand, the server is probably in some data center. It's probably high powered. It probably has a very, very strong internet connection. So all requests from the server to your data can be very quick in comparison to your browser. Then it's also optimized for search engines, because now the first initial response in the first 2-3 seconds is actual data with actual content which Google can index. And because you can split off certain parts of your server rendering into just server code, it allows you to access private data. So you can leave your API key, your database credentials in there, and query the database directly. What are the cons? Well, the mental model is a bit more complex, because now you have to think about, okay, what will just run on the server, what can only run on the client, and what code should be able to run on both. This takes a while to get used to and to figure out the edge cases around it, but I think the trade-off is worth it. And of course, the biggest con actually is now you need servers, and you need to pay for servers, and servers can get very expensive if you have lots of users. Now, how is routing? Oh yeah.
Maybe just a question before we
Cool.
move away from this. So basically, the server will know when it's your initial page request, will then render the data for you,
Yeah.
give you everything you need, but from then on it's still client-side rendering.
Exactly, yeah.
Okay.
So I'm using Next.js for this project. How is routing and rendering done in Next.js? Well, Next.js is actually a very progressive and very cutting-edge framework. It's actually one of the first ones to introduce server-side rendering in 2018. And defining a route in Next.js is actually very simple. You just have to add a file into a certain folder. So if I want to create the route /dashboard/settings, I add a file called page.js into the dashboard settings folder. And if you export a function from there, it will be your route. So how does it look like? Well, this is the whole first part of the route for the candidate profile. And as you see, we export a function called candidate profile here. And it takes a parameter called candidate slug. And the reason it takes this parameter is because the route is called /candidate slug. And everything you put into the brackets will be a parameter your function gets. So you can dynamically respond to certain requests. Yes?
So where do you define the route? Is that in the config file?
No, here. It's in the file system.
No, I mean the parameter, like the candidate slug parameter here.
You define the slug number. It's just in the params. So the params are just a dynamic object which gives
okay,
you
so the contract as to what kind of parameters you get in is just defined in this params object here.
Exactly. This is something I actually don't really like about it, but it's a good point. You define this with yourself with TypeScript. So in this case, I have like a type annotation which just tells my code that this param will be candidate slug. So after we define this function, we can write the routes. And the first thing we do is do data fetching. So we want to find the candidate with this name, with this slug. And the valid slugs here are Andreas Babler, Pamela Rendi-Wagner, Hans-Peter Doskozil. And to get these valid routes, we have to actually fetch from the database. So what we do here is we are calling Prisma. Yeah?
Question. Do you know why it's called a slug by any chance?
So the question was why it's called a slug, and I have no idea. It's just something I found out one time and now I use it.
I think it refers to the last part after the slash.
Yeah, but do you know why it's called that?
Maybe because of slugs, because they're trailing behind like the...
We can maybe Google it later and find out. Yeah?
So the string that is all lowercase and only like letters and numbers and underscores is called a slug. So I think it's really because of the
I mean, it makes sense, yeah? Well, let's Google it later to find out.
There's a Stack Overflow post.
And?
Yeah, it's a long explanation.
All right, you can maybe read it while I talk about the routing. So we are fetching the candidates, and the first thing we do after fetching the candidates is check if it's actually there. So if the response was actually something meaningful and not just an empty array, for example, or an empty object. We just check against the candidate if it's a Boolean false value, and if it is, we throw a not found, the routing stops, and we'll show a 404 page. And afterwards, we are just returning a React component, which is basically like a Vue component, just HTML with JavaScript sprinkled into it.
Okay, just to clarify, so if this is the first request to this page,
Yeah.
then that React component will be rendered on the server, and just the HTML will be sent back.
The HTML and the JavaScript responsible for it.
Yeah. Okay. Yeah. Okay. So Next.js has some, I guess, HTTP header that signifies whether this is the first request or just a subsequent request on the client.
The way it works, and you can look at it in the network tab how it's done. So the first request will be from the browser to the server with the full URL, and then it will respond with the default, which is HTML and the JavaScript bundle. But afterwards, you're no longer requesting the full URL. You're requesting a special HTTP GET route from Next.js, which is all done in the background, and it will never see it except in the network tab, which will define the route you want, and will return the data you need for it.
Got it. Okay.
So after the second request, it will be all on client in server-side rendering, but I will get to that in the next slide. Okay, so how do I actually render mitentscheiden.at? Well, actually, all components are mostly rendered on the server and never sent to a client. So these components can fetch data directly from the database because their code will never be sent to a client, which allows you to actually do this. Because why the hell can I call a database from my React component? The answer is React Server Components, which is a new feature, I think released like 9 months ago, which allows you to define certain functions as async, which will run just on the server and will never be sent to a client. The only component which is actually rendered on the client again is the questionnaire component, which is responsible for rendering this here, the whole questionnaire. And this component gets passed certain data, like the questions, from a React Server component into its server-side rendering. And on server, it will render this data into HTML and then hydrate it on the client to become interactive. And this allows for certain behavior, like saving the in-progress questionnaire to local storage, which just is a nicer way to interact with the page without having to do a full HTTP request every time you want to change something. Now, caching. Caching is the first and many times the last thing you will need to scale application to hundreds of thousands of people. And ABC, always be caching. And caching is very simple. Caching just means taking something which was expensive, like a database call, and saving the results for certain periods into a place you can access quickly and cheaply. So Next.js actually allows you to define caching strategies for every page as well as every fetch inside the page. So you can say the whole page is cached for a day, but also maybe some fetches inside the page can be cached for a year, for example. So it will only re-execute after a certain time. But there are also different kinds of strategies for caching. And in Next.js, the following are supported. The first is static. And what static means is the data will only get fetched once when the application gets deployed or redeployed. And after that point, it will never be refetched again. And it will be always a quick response because it's in the cache. The next is the other side of the spectrum, dynamic, where every request gets fresh data and every request takes a bit to fetch the data. This is, for example, useful if you have an app behind login, for example, which needs to check against the database if this user can actually read this data or not. And the last pattern, which I use the most, which is the most powerful, is stale by validate. And this works by you setting an interval of maybe 60 seconds, maybe 3 hours, maybe a day. And in that time, if the request has been sent in the last 60 seconds, after the last data fetch, the cache data will be shown. And once this interval is done, so after a minute, for example, it will still return the, I'll give you a second.
Cached on the server or on the client?
That's a good question, actually. It's a bit hard to answer because in Next.js both, but usually on the server. But you can define caching in both places. Where was I? Yeah. So after the set interval, a request comes in. It will still return the old data, but in the background, it will re-execute the fetch and provides the fresh data to the cache, allowing thus to have the next request with new data. This way, you can update data in a certain interval, like maybe every 5 seconds, but still always have a quick response because every response will be cached. So now to the last step. How do you actually put an application on the internet? Well, I'm going to give you a bit of a history of how it was done before. And in the olden days, let's say in the 90s, you really had on-site physical servers. So every company like Pets.com or Amazon had their data centers, sometimes a server room in their company. And they need to buy hardware, they need to configure RAM, they need to install the operating system. They need to talk to their ISP to get good networking and all that stuff. Handle security updates, for example. All very annoying tasks. Every time a bit of a possibility to fuck up, actually. The next step, which happened in the early 2000s to end of the 2000s, is virtual private servers, which is a way of virtualizing an operating system on the hardware. And this allowed data centers to actually have one big computer, which runs 100 instances of some private server. And for you as an end user, you no longer have to buy hardware and ship it somewhere. You can just click a button on the web page, and you get your server configured, you get an IP address, you get some login data, and it's yours. The next step after that, let's say in the early 2010s, is the rise of platforms as a service. These are even more abstracted because now you're no longer thinking about hardware or like what Intel processor you want in the server. You're actually thinking about, okay, what code do I want to run? Do I want to run a web server, for example, or do I want to run a database? And you can rent directly a ready web server, all configured, and you just bring your own code. This has the big advantage of not having to manage an operating system. It's just there, it will work, it's updated, the platform will handle all that annoying stuff for you. And the last iteration, which is, let's say, 4 years old, is serverless functions. Here, the server itself is abstracted away as an idea. And again, you're just thinking about your code and data. And I will get to the functions in the next slide. And here you can see a bit of a range of what the different options mean. So at the top, you have more control. It's all yours. It's your hardware. It's your software. And you can change everything, but you can also fuck up everything. And if you go down the list, less options to fuck up, but also less control over what's happening. So how do serverless functions work? Yeah?
Can I go back to slide 4?
Sure.
What is the difference again between platform as a service and serverless?
That's the next slide. So, but it's a good question. It's basically the same, right? You only think about code and data. And the important distinction is that you're no longer thinking about servers. Because in serverless functions, the idea of servers are kind of gone. Because a serverless function spins up every time for a request. So, for example, you're requesting the index page. The data center where you're hosting the functions gets a request. And it'll then spin up a new instance of a server. It's not completely serverless, just hidden away. And it will execute your code, which you have defined, and return the response. And after returning the response, it will shut down again. So why would you do this? Sounds kind of weird, right? Well, the pro of this is we'll use exactly the amount of compute you need. For example, if you have 100 requests a day, which all take 500 milliseconds, the server, if you have a real server, will just stay there and do nothing for the rest of the time. With serverless functions, you just use the amount of compute your requests needs. And this has two very interesting and very different applications. The first is scale to 0. So if you get no requests, there's no compute needed, and you pay nothing for it. Which is, in most cases, very useful for things which have, let's say, very few users. You want to ask a question?
I maybe want to add to this because it is a good question between platform as a service and serverless.
Mm-hmm.
I think that there's maybe a slight distinction that I want to add there. That in platform as a service, you do have a bit more freedom as to what you can put into what is being executed. Where in serverless functions, you could really just execute a function. And if you have a platform as a service environment like Heroku or what have you, or Google, what's it called? Compute Engine, I think, right? Whatever Google is doing nowadays, I don't know. Then you have a runtime, and you can still run an application in that runtime. And you have a lot more freedom how you organize your files and your code.
Actually, that's not true.
Huh?
So in serverless functions, it's called a function, but you can also just, Next.js is a whole project of a lot of files and file organizations. You can still have multiple files.
Even in like the Azure functions and stuff like that?
Yeah.
Really?
Pretty sure,
then I haven't kept up to date with the stuff. All right, so when I was up to date, which was like a couple of years ago, it was actually just a function that you can run.
Yeah.
And you were a lot more restricted as to what you can actually run to enable the whole temporary compute environments.
Yeah, so apparently the tech has progressed a bit. I mean, in the background, it's still a function which you call, but this function can import a whole project.
Right. No, that's true. Exactly. Right. But my mental model of a platform as a service is you're getting a runtime served to you that scales automatically.
Mm-hmm.
Good question. What the difference to serverless functions is then, right?
But the difference is the serverless function starts up and dies again.
Same for platform as a service.
I'm not sure that's true.
In Heroku it was, for instance.
In Heroku you can set it so it's like works like that, but most Heroku apps will have a long-running server which will have background processes.
That's right. So I guess maybe the
heaviness of the runtime.
The heaviness of the runtime, and I'm guessing the amount of time that the server stays up.
Yeah, I'm assuming Heroku will have like a certain cooldown period and then will shut down again.
Exactly, yeah.
But in most cases, if you have an actual platform, application which has to run for multiple requests, you will not set the shutdown
2 seconds.
For Heroku.
Yeah, right.
Yeah.
Just to add on to this, so would caching then still be possible at these servers though?
Yeah, that's actually a good question because you're right. Caching normally in the old paradigm happens on the server. So you have like some sort of caching mechanism, maybe the file system, maybe a Redis database which will store the data. With serverless functions, that's not possible because they die again, of course. And here caching is done by different servers. And that service is a CDN we mentioned before. So the clouds you're using will mostly likely have a CDN service behind it as well. So every request will first go through your CDN, and if the CDN says, oh, I need new data, it will actually only call your functions. And if you return data, this also goes through the CDN and will cache it depending on your strategy. Oh yeah, so the first thing is scale to 0, and the second thing is scale to millions, because the cool thing about functions is it forces you to architect your code in a way which allows you to run it in parallel, because if you get 10,000 requests in 2 minutes, it will probably spin up, let's say, 500 serverless functions to handle those requests. This allows you to basically scale for free without thinking about it, because now you don't have one server, you have 10,000 servers if you want them, or 100,000, or 10, depending on your request load. Now the cons, and this is the switch in the mental model, is you don't have long-running tasks. So you can't have any background processing happening, and every request will just exist for the 2 seconds at most it can run. I think it's 30 seconds for certain functions. Then there's a higher cost of this, because it's a very, let's say, compute-intensive thing for a platform to offer, because these servers will still need to be somewhere and be handled somewhere and spin up and die again and be managed. And after hitting certain limits in your clouds, it will be very, very costly. And the last issue, which is one of the biggest for actually delivering a good user experience, is cold starts. To explain cold starts, I need to explain to you the 2 types of serverless functions which are currently offered. So the first is a lambda function, and this is basically an invention of AWS, so Amazon. And a lambda function boots a fully virtualized container running, which will run your code. And this will work with many languages, like Java, like JavaScript, Python, Ruby, basically every language you want can run on this runtime. It takes about 100 to 300 milliseconds to boot up, because it will actually boot up a small operating system onto a container and then have to load your code in and then execute your code. And the first 100, 300 milliseconds of loading up the operating system and your code is called a cold start. The other type of serverless functions are edge functions. This is also a very new invention. These functions don't boot up a fully virtualized container. They actually boot up a runtime which is very similar to the browser. And if you ever open up a web page, it doesn't take 300 milliseconds to boot. It's instant, right? Well, it's basically the browser runtime, and it just works with JavaScript. And it takes around 0 to 5 milliseconds to boot up, because it's instant. And usually, these edge functions are distributed worldwide, so it's the closest to a user. So if you have a user in Japan, it will get the edge response from Tokyo. If you have a user in Vienna, it will get an edge response from Frankfurt or maybe Vienna even. And wait, what was the question somebody asked, which I wanted to explain? You, right? Oh, wait, no, sorry, that was the slide before. Yeah, sorry?
I just wanted to ask, now for the lambda functions, there's like a major loss in response time, the 100 to 30, like 300 milliseconds.
That is correct, yeah. So the lambda functions have something called a warm phase. So if you get 10 requests in the same seconds, it will stay warm and it won't be 300 milliseconds, it will be 100 milliseconds of response time. But if it's a first request in 3 minutes, it will probably be not warm and will not be cached, and that's why it's going to be slow. Yeah?
How do serverless functions handle state?
That's a good question. They need to handle it somewhere else, maybe in a database, for example.
Okay, but that's then quite a bottleneck right there, right? Because the growth of the serverless functions from 0 to 3 is easy, but then you still have, you just
That is an excellent question. You're 100% correct, yeah? It's a new challenge, because now you have to work on a different place. But think about it that way. It's the same problem again. Beforehand, you had the database, for example, which you need to scale, and your server. Now it's just a database, right? And I'm actually going to answer the question in the next slides. Was there another question somewhere? No, good. So these are the edge functions and lambda functions. And as you can see, lambda functions are more powerful because you can run anything. Edge functions, less powerful, but very quick and very easy to distribute, and also very cheap. So the going price for edge functions are about 50 cents for 1 million requests, which is basically nothing. So how did I deploy mitentscheiden.at? Well, first, and this is the answer to your question, serverless database. This database is called Planetscale. It's using MySQL under the hood, and it's using something called Vitess, which is an open source scaling solution for MySQL. And the cool thing about Vitess is it was developed by YouTube and open sourced by YouTube to handle their scaling needs for running YouTube, of course. And the fun thing about Planetscale is you don't pay by some fixed monthly price for performance, because performance will always be the top shelf. You pay per row read and row written and gigabyte stored. This is a bit of a Wermutstropfen because it's cool and it gives you the highest performance, but if you don't write your queries efficiently, it's going to be very expensive to run all those row reads and writes. But the cool thing is it can support up to, I think, 10,000 concurrent connections to the database without losing any performance. So if you get 10,000 requests, which all open up database connection, it will work fine without an issue. And another cool thing, which is a bit of a side thing, is it supports database branching, which means if you want to have a different instance of your database to test new data or test a new schema for your data, you can run one command in a command line and get a completely new instance of the database and just do what you want with it. And if you're done, just close the branch and you're ready to go. Now for my serverless hosting, I'm using a platform called Vercel for serverless functions and the CDN. And Vercel is basically just a pretty UI and a good developer experience over AWS and Cloudflare, and they're just repackaging the compute of those platforms. And their main selling point is that it's very easy to deploy and very easy to create temporary instances of some feature. So for example, if I'm building a new feature with new code and new endpoints, I can just create a Git branch, push it to my repository, and Vercel will automatically deploy it to a new URL and have a separate instance for it. This is cool if you're alone. It's amazing if you're like 10 people in the same team doing the same on the same project. So, total hosting costs. Any guesses? How much? Oh, let's give you a number. We got about 210,000 page views and probably around 500,000 requests because of crawling and stuff like that. Any guesses how much I paid for this? Or the SPA paid for it?
Per month? Or
It was around a month, yeah, of like having it live.
100 euros.
I got 100 euros. Another question? Another idea?
20.
20? Anybody else?
150.
150? Anybody else? Actually, the cost was 0. Both Vercel and Planetscale have very generous free plans. For example, my Vercel plan, I run like, I think 20 projects on that. It's still at 10% usage. And this project was around 2% of that, or maybe 3. Planetscale was a bit more. I was a bit, I think 10% utilization of the free plan. So also a lot of room to grow. So probably we could have gotten to 1 million page views without leaving the free plan. Yeah?
So you basically hosted your website on servers for free, or
Yeah.
you have your own servers?
I don't have any servers. The only servers I have is like for some very old projects I have of like some friends of mine running on some old tech. But I pay like $20 a month for my Vercel, but I can also run this on the free plan. I just have a pro plan because if you are using something on Vercel for selling a service, you need to pay for it. But if you are just having a free project, for example, with no money transacted, it can be on the free plan. Yeah?
Do you understand correctly that like, the advantage of serverless functions is that it always shuts down and you don't have to pay like, for the whole runtime?
Yeah.
But there still must be some server that like intercepts the request
Yes.
and you don't pay for this one.
No, we don't pay for this. This is something which these platforms can do because of the big cloud platforms, so Azure and Google Cloud Platform and AWS, because they always have this compute running. It's always there. It always needs to be there because they have like 1 million customers. And because they have 1 million customers, the marginal costs of the next customer is basically 0. And this allows you to offer this. So my main thing I want to give to you is that you can do this too. It's not that hard. It's free, mostly, and it's a lot of fun. And my number 1 tip is actually build things. It's fun, and it's the best way to learn web development and actually basically learn anything. So find problems in your daily life. You want to fix the software, and then just do it. And it's going to take a bit. It's going to take a lot of Googling, lots of failing, lots of fucking up, of course. But it's a lot quicker than you might think. So if you're at this semester of doing web development and you had fun doing it, I can highly recommend it as a career. It's quite well paid. It's very fun. And you get to show people things you've done, and they are sometimes hyped about it, sometimes not. And lastly, I'm going to leave you with some great tools you can try out, which are free. So for full stack frameworks, I can recommend Next.js and Remix for React, Nux for Vue. For serverless hosting, Vercel, Netlify, and Cloudflare are basically the same thing. Bit different pricing, but also all with a very generous free plan. For databases, I can recommend Planetscale, Supabase, Neon, Railway, and Sanity. You get the slides later. Don't worry about it. And for repository, yeah?
No Postgres?
Postgres is a database. These are services. So Supabase and Neon and Railway all are Postgres. And Planetscale is MySQL, and Sanity is a headless CMS, which is something entirely different. But you can, with Sanity, you get like an admin UI as well as the data, which is nice for normal people. Yeah?
Do they run on your server?
No. All these are.
Separate server.
These are all separate servers, all managed by the company behind it. And after a certain point, you will have to pay money for these, but they all have a generous free plan.
Do you know how they are with, supposing you have to store some user data?
Yeah.
How are these to work with, especially all the serverless stuff, regarding compliance with data privacy laws?
That's a great question. Actually, a very interesting thing I've been also working on for a side project, for a blog post. You're correct. These are cloud platforms that are worldwide, and you don't want your data in the EU going to the US because of DSGVO. The cool thing is, for most platforms, you can just set, I want my functions to run in Frankfurt. I want my functions to run in Vienna. I want my functions to run in Norway or something. And this way, the data or the request stays in the EU, and for your data, you can do the same thing. So for Planetscale, I had the server also set in Frankfurt. Yeah?
How do you develop? Do you use the services as well on your local machine, or do you have something else? Or do you reuse the production database?
So there's like two approaches to this. The first is all these tools I'm recommending, except Sanity, are based on open source solutions. So for example, Railway and Neon and Supabase are Postgres, which is open source, and Planetscale is MySQL. So you can theoretically run a local instance of MySQL or Postgres on your laptop and develop against that. And once you want to deploy it, you deploy it to the cloud where the database is in the cloud. I don't do that because it's so cheap, I can also develop on it. So I will just connect to the cloud database from my local machine.
Do you then develop on the production database, or do you have two separate databases?
So for a Planetscale, as I said before, there's this database branching. So I use that. So I have a development branch and a production branch. I think Neon has the same feature for Postgres, and I think Railway as well. So you can get automatic development, staging, and production database instances for your needs. And if you don't, you just create a new database for just development. Then you have like a development and a production database, and just switch the variables for it. Lastly, for just repository and project management, I like to use GitHub, Linear, Trello, and Slack. Just that you heard about those ones. And now, yeah?
So you've introduced many services. Do they run each on, do they all run on different servers, or can we organize them on a single server and do all the logic there?
So all these paradigms work in serverless and also normal servers. So with serverless, you don't have any servers, of course, so you can't run them there. So they all need to be in the cloud, they all need to be internet connected, they all need to be accessible by some URL, basically. So you do have separate servers. In most cases, you won't manage those servers directly. You have like a company behind it which does it for you, which is nice because you don't have to think about it. But you can run all of this on your own. You can have it on a Raspberry Pi, basically, if you really want to. And Next.js runs on every, I think, Node runtime as well. So you can just run it in Node.js. And the database can just be Postgres or Planetscale or SQLite even, which is just a file. And also, excellent database.
So the question was also from my part. So the database is run on a separate server than the business logic.
Yes.
So there's just, you just write SQL and it's not like a database file on the server, but it actually goes, like the SQL code goes.
It does a network call, yeah? Yeah, it does like a network call to some other instance. This is actually a very good question because usually in a database it's connected to your business logic directly. So the latency is like 0 or 2 milliseconds. It's very quick. The cool thing about the cloud is that all these data centers are in the same place and the networking inside these data centers are like insanely fast. Think like 100 gigabytes per second, something, or whatever the limit is. So for like some real data, because I analyzed this, of course, it takes about, I think, 30 to 50 milliseconds. Oh, wait, no, that's the total response time. It takes about 10 to 30 milliseconds for your serverless function, for example, to get data from your Planetscale database if it's in the same data center. If the data center is on the other side of the world,
It could be one data center but two separate servers.
yeah. So
it's in the same location.
basically, so you have to dig into it a bit because different services use different hostings. So, for example, if you have the same AWS location, so it's all in AWS Frankfurt, for example, it's got to be the same data center, even though it's a different company. But if, for example, you can run Planetscale as well on Google Cloud Platform if you want, and then it's going to be a different data center, but also very fast. In my experience, the performance hits won't come from putting your database into the cloud. It will come from not caching properly. Because in reality, you want your database to be hit as least often as possible. But I'll open up for questions in a bit. I want to do the last slide for a second, okay? I'm going to leave you with some resources. So the first is, here's a list of about 300 plus developers you can follow. Jürgen will send you the slides later. This is my personal list. These are the people I like, the people I follow, and they're all doing like cool projects. They're sometimes working for these companies I'm showing you, and sometimes they're just like people like me doing cool projects. Then I have like 2 recommendations for YouTube or Twitch. The first is Fireship.io. You might know it. They do like these fun 100 seconds videos showcasing some new technology. And the other one is Theo. He's like a streamer / YouTuber. And he just does like very interesting explainer content on web development. The other tip is local meetups. There's Vienna.js and React Vienna, which I go to. And meetups are great because there's some company hosting it and offering free food and free beer just for you to be here and listen to some talks. And of course, they want to recruit you, so it's also a cool way to just get a job, for example, and get to know people. So most open source people who are like working on open source software in Vienna go to these meetups. And you can just talk to them. They're normal people, they're very nice, they don't bite. And the last tip is follow me on Twitter @Kritzit. Please all take your phones out and follow me. And I think I'm done. Questions?
Yeah, thank you very much for the fantastic talk. We have time for a couple of questions. I think we already had a lot of discussion, which I think was great. Are there any remaining questions so far?
Just generally speaking, so serverless, I mean, I assume that's a broad statement, but I assume it depends on the use case, right?
Yes.
But if you have just an application which I guess has some simple logic and doesn't need like states or anything specific, you can just serve them the answer once and call it a day, and then serverless would work really well.
Yeah, for any
The
use.
question is like, what use cases have you used serverless for besides this one?
That's
Have there been projects where you would have preferred the other one or things like that?
That's an excellent question because you're right. So the perfect use case for serverless is something where everything you need will be inside your own code and you don't need any external sources because that is perfect. Because then you will just serve whatever the requests ask for, and you can scale to infinity, you can scale to 0, and there's no other consideration. Serverless gets more complicated if you have different kinds of data sources you need to integrate, but also it's very complicated, or it takes different infrastructure as well if you want to do some async processing. So for example, for the streamer I built the app for, I need to sync with YouTube somehow. And I cannot do that on some server in the background because there's no server in the background, it's just the functions. And the easiest solution to this is, for example, Vercel offers a cron job functionality, which is basically just an interval you set like every hour, every day to run your serverless functions again. So I have like 5 different functions, which are all like for syncing a channel, syncing a video, and matching the tags, for example, to the channel. And this is how I do like the async processing. I would say anything where the part of rendering to the client is not that important, you can just use a normal server. So if you just need something which just runs a long time, has some background processing, then serverless might not be for you. But honestly, the main reason I use serverless is because I don't want to manage servers. It's very cumbersome. You need to SSH into some IP address. You need to configure some vhosts and all this shit. I hate that. It's so boring. I just want to write code and deploy it via Git. And serverless just offers you the best developer experience. And it's very cheap if you stay in the limits, of course. Once once I hit the limits of my pro plan, for example, which cost me $20 a month, I think I'd pay 100 times the same price for the same usage again. At that point, I will probably switch to some other provider, but yeah. Yeah?
How long did it take for you on average to deploy your projects?
You want to do something fun?
Sure, yeah.
I'm going to deploy a project right now.
This is an official speedrun now.
Oh, fuck.
It's just worth it up.
Hmm?
Just not an experience, just put this hood up because people can't see otherwise.
That'll just do.
And increase the font size a little. Yeah, right.
Okay, time starts now.
Well, I think the longest will be to install this thing. Test. Yes, TypeScript. Yes, ESLint. Yes, Tailwind. Blah, blah, blah. Sure. Sure. So this is installing now. And it's going to take a bit. Yeah. This is the default Next.js starter thing. So we'll just install the defaults of Next.js, and we'll have like a getting started page.
Do you want to change something? Like something small?
Sure.
Yeah. Yeah.
35 minutes before your laptop runs out of batteries.
No, that's not reliable. My laptop is dog shit.
I don't have a charger with me.
I have one.
Okay. I think
We won't. This laptop is really not reliable.
This is my old laptop?
No, you got me this from like some failed startup for
Oh, yeah, I
$1,000.
remember, yeah. I remember now.
How did it get there? Oh, thanks. Fuck! Is it gone?
Oh, no.
Fuck. As I said, 30 minutes is not reliable.
All right. Okay, so in the meantime, maybe, are there any last questions for Christian?
Yes.
I think, yes.
So just another curiosity question. So let's say you'd have to do a complete static HTML page, which now is rare, but if you do, would you then just need a CDN just to
Yes.
put the files?
Yes.
That would be like the easiest lightweight.
Yes. It's the fastest, easiest, the best.
And I
Just
think
a CDN.
Cloudflare offers that kind of stuff, like out of the box, right?
Yeah, Cloudflare,
Yeah.
Vercel, AWS, every platform has a CDN, and it's mostly just free.
Is there a difference between these and then where most hosting platforms offer like some managed web servers, where you just pay basically
Yeah.
on your website and it's shared?
So these are like the virtual private servers mostly, and they usually don't have the optimizations you need out of the box. So they don't offer CDN, for example. It's really just a computer in some data center, and the request just goes there, and there's no caching. So a CDN is really the best option for it. Damn, the laptop is not starting.
All right. There's a question in the back.
Yeah.
From what you set up to now, you sound like a hardcore JavaScript programmer. What other languages do you use other languages, and if so, which?
Yeah, so
The question was, do you use other languages?
Yeah, true. It's starting, nice. So up until like 2020, I was not really writing JavaScript or React actually or anything else. I was a PHP developer, and at Xing I was doing like backend PHP engineering. And beforehand I was doing like a bit of Ruby, a bit of Python, but also mainly just PHP and just basic HTML, CSS, JavaScript. And in 2020 I just wanted to like learn something else, and I had like this one project, the film festival, which needed to be like a bit more fancy, and I just decided to learn something new, and that's how I got into using JavaScript and TypeScript. Yep.
When you use these different providers for like your database and the hosting and everything, can you switch between them, or are you locked in? So when you develop something and then, I don't know, some provider changes their pricing or something, do you have to rewrite your code, or is it easy to switch?
That's a good question, and it's something I'm actually very careful about, because I don't want that to happen. I don't want to change my code a lot just to switch providers. And this is one reason I'm not that hyped about Next.js anymore, because they're introducing lots of features which are a bit not transparent on how they work. And this makes the platform login a bit more of a consideration. But mostly, I don't really have to change the code. So most platforms, if they support lambda functions, which are Node.js, can run anything. And for edge functions, it's even better because it is just a browser runtime, which is actually quite universal. So if you write your code for edge, it will just work. The same is for the database. So I'm not using some like custom data storage data solution with some more fancy features, because I don't really want to be locked in by my database. Especially not my database, because it's like the core of your whole application, and you don't want to really have that in just the hands of some company. So if I want to switch from Planetscale, the thing I need to do is just export the data and import it to another MySQL instance. And the cool thing about Prisma, for example, is I don't even have to do much to change to a different database, because Prisma handles all that for me. And if I want to switch to Postgres or the SQLite, I just change one line, and Prisma will generate a schema which is compliant to the other database. And all my queries and insertions, all that, will also be automatically handled by Prisma.
Generic. So you're writing generic statements.
Exactly, yeah.
That's cool.
Okay, so we are here. Hello, web. It will be very embarrassing if I misspell engineering. And I say Vercel, I think it's deploy. Let's see. This will take like 30 seconds.
So any last questions, Christian, before we then see the final reveal?
I think
You got an error, maybe?
An error?
Yeah.
we're not on the network yet.
Oh no. Oh yeah, I need my hotspot.
Don't you have Ethereum?
I'm no longer a student.
Are you not?
No,
Okay.
I'm no longer mooching off the government.
Yeah.
No offense.
I might have a question. Another question.
Yeah?
Oh, yeah, sorry.
Have you ever made big optimizations to a website to just let it run faster? And if yes, what were the main bottlenecks?
Yeah, I actually did it often. So, it's a good question. So the main thing, wait, I can maybe show a tweet later. So one thing which you have to know about Planetscale, for example, is that because of Vitesse, the scaling solution, you don't have native foreign key functionality. This is just how Vitesse works, because the foreign keys make it harder to scale the database in some way. And this means you can simulate the foreign keys via Prisma, and it works and connects together. But you need to manually add indexes. And an index is basically just an internal database storage for knowing which thing is where. And normally, if you have a foreign key, it will just create the index for you. Planetscale didn't do that for me, and I forgot. And that's why it took a bit, I think, 5 to 6 times more row reads than needed. And I just changed 3 lines of code, and the code ran for, I think, 200 and 100 milliseconds faster. Another thing which I fucked up is that I forgot to put my server and my database into the same data center. And I had one in US West and one in US East for this streaming platform. And just the speed of light between these two is around 50 milliseconds. So it took about that to get from and to that. And I just moved it to the same data center with 1 click, and it worked. That's like for serverless stuff. And for anything else, for every like normal non-cloud hosted platform, caching is a big thing. Just put a CDN in front of it for many pages. Oh yeah, let's do this. For many pages, so if you have like a WordPress blog, for example, there's like a Cloudflare plugin you can install which automatically optimizes your whole page. It will optimize the images, it will optimize the fonts, the scripts, the HTML, and that will be a big performance boost. So just caching on some place which is not some VPS server is a big performance improvement. And for just general like web performance, the biggest thing is images and scripts. So optimize images, make them smaller, deliver them in a better format. Next.js actually does it for you if you use their image component. And for scripts, the main killer of performance is just like Google Analytics or other scripts like that for the marketing department, like the Facebook pixel for tracking. All that stuff will just kill your front-end performance. So there's also optimizations for that in Next.js, for example. So it's building right now. We can actually inspect this.
It's front-end web page.
This?
What are you deploying?
I'm deploying a Next.js app, which is a full stack. Yeah. But I'm assuming there's no data fetching happening. And this is like this is Vercel. It looks very nice, very cute. And it will show you how to build it. And I think it will be done now. So it took that one command, Vercel deploy.
I think with that we can close. Thank you very much again, Christian.
Sure thing. Yeah?
Okay, one more question.
So just so I understand this, so when you're writing a serverless, you're just writing functions.
Mm-hmm.
So just simple functions, but what part handles the routing and rendering and all?
Yeah, but I'll show you on this project. So the functions.
Do you still upload like a whole project, or you just upload like one TS like file which has a lot of functions in it? I don't like fully understand.
Yeah, that's a good, that's an excellent question actually, because you're right. It's just like a function. How does it work? How can you load a whole project into it? The secret behind it is just some gluing code the platform writes. So for example, if I add a new project to Vercel, it will ask me if I want to browse a template. And they just have like starter kits, and they just detect the project configuration and will know how it works. So for example, if it's a Next.js app, it just knows it because Vercel creates Next.js. But if it's like a Vue.js or Nux.js, they also know how Nux project works, which config files it has, how it like compiles together. And I think they even have like a API for framework authors to build a certain compile step for Vercel. So it's just some magic under the hood, but it's not that complicated. It's like 10 lines of code or 20 lines of code. But you as end user or like as developer will not see it, let's say like that. Yeah.
So you really are abstracting yourself from what's happening. You're just writing the code.
Yes, that's the cool thing about it. You're not thinking about, oh, how do I host this? How does it run? What server runtime is there? You bring the code, and the platform knows what you need. And this is a bit of the future also of like the space, where you're no longer thinking about a database or like a database server. You're thinking about, oh, I want my data stored in a certain way. And in the future, probably we'll just say, oh, import database, and the platform will know what you need. So it's already happening. Vercel has like a database offering, and you just import Postgres, and it's done. Yeah?
Is this the tablet for question?
Yeah, sure.
Okay, for asynchronous interactions,
Yeah.
does it also map it to like a new endpoint where it then calls the function, or how does it really then?
So, for example, I have like a sun up, and I have an endpoint which syncs channels, which just calls, I think, the YouTube RSS feeds, and I just defined it in my project under this route. I don't have it open. And this is a different function. So if I want to sync a channel, for example, I can just call it like this, and it just works like that. So it's, I map it to the URLs. This is something you can decide on your own. You can also have just one URL with many parameters. You can have different URLs. There's also libraries which handle that for you, for example.
Any last question? All right. Now, really, thank you very much. Last time.
Thank you. Damn, it's my payment.
Yeah, exactly. All right. Very good. Okay. How is everyone feeling? Because this took way longer than I thought. Thank you very much for all the questions. Thank you very much for the talk.
Of course.
It was great. Can you keep this here for a second?
Oh yeah, sure. Wait, then I will.
Yeah. Are there questions? Like this is it. This was web engineering. We will grade your